I'll do 16 and 17 here together. This is a hypothesis test. Okay, so hypothesis test, the same 5 steps we'll be doing. State the null and alternative hypotheses first. So the null hypothesis says that P1 is 0.35, P2 is 0.25, P3 is 0.2, P4 is 0.1, and P5 is 0.1. The alternative hypothesis is going to say that P1 is not 0.35, P2 is not 0.25, P3 is not 0.2, P4 is not 0.1, P5 is not 0.1. Step 1. So step 1. Step 2. What's step 2? Calculate the critical value. Get your critical value. So if I go back to my table, my formulas, right? The degrees of freedom, number of categories minus 1. Degrees of freedom, number of categories minus 1. So my degrees of freedom here, I have 5 categories minus 1. Degrees of freedom are 4. 4 degrees of freedom, 0.05 level of significance. Let's get that critical value. Chi-squared, right? And remember chi-squared, that critical region is to the right, yeah? I forgot already. 4 degrees of freedom and 0.05. 4 degrees of freedom, 0.05. 9.488. That's our critical value. 9.488. Step 3, calculate chi-squared. And if you remember, chi-squared is the sum of the observed minus the expected squared divided by the expected. We need the expected values. We don't have it, right? So if you need a refresher on this process, finding the expected values and finding chi-squared, number 15 gives us all of that. Okay, so let's find the expected value. So the total, first of all, the total is 49 plus 34 plus 14 plus 9 plus 10. Let's sum those in here. La la la. 49 plus 34 plus 14 plus 9 plus 10. 116. Okay, so let's get the expected values now. So I expected category 1 to be 0.35 of that total. So 0.35 times 116, 40.6. That's what we expected for category 1. 40.6. Category 2, we expected to be 25% of that total. Whoops. Sorry. 0.25 times 116, 29. Category 3, we expected to be 20% of this total. Well, if 10% is 11.6, 20% would be 23.2. 10%, 11.6. That's 23.2, right? And 10% is 11.6. Okay, so there's our expected values. And now you can do this by hand, just like we did in number 15, right? I can do 49 minus 40.6 squared divided by 40.6 plus 34 minus 29 squared divided by 29. 14 minus 23 squared divided by 23.2, right? I'm not going to do it that way. I'm going to show it again with the calculator so we can get comfortable with that. Clear lists, second memory, 4, clear all lists. I'm going to go to stat, edit, and I'm entering, in L1 I'm entering my observed. L2 I'm entering my expecteds. Okay, I'm going to quit out of there, second quit, get out of there. And then a second list, math for those lists, and then sum. So my parentheses, so sum of L1 minus L2, close parentheses, squared, divided by second L2. Observed minus expected squared divided by expected. 7.05 is my chi-squared. So if I'm thinking about this, right, my critical value is 9.488. And remember that chi-squared is positively skewed. So that chi-squared value, that gives me this 0.05 here. That's 9.488. That's my critical value. I calculated my test statistic, my chi-squared test statistic. It's 7.05. That's less than 9.488. That's here. That's not in the critical region. Do not reject the null hypothesis. Do not reject the null hypothesis because we're not in that critical region. That's it. That's the test. Test is done. That's it. 17, we're going to do the exact same thing. So step 1, I'm going to write the null and alternative. Null, P1 equals 0.45, P2 equals 0.25, P3 equals 0.1, P4 equals 0.1, P5 equals 0.1. So the alternative is P1 does not equal 0.45, P2 does not equal 0.25, P3 does not equal 0.1, P4 does not equal a tenth, P5 does not equal a tenth. Step 2, critical value. So I need degrees of freedom. That's the number of categories, minus 1. So 5 minus 1, that's 4 from our trusty formula sheet there. And I want to find that critical value now. So 4 degrees of freedom, 0.05. Well, that's the same as before, isn't it? That's boring. 4 degrees of freedom, 0.05, that's 9.488 again. So I'm thinking the same thing, right? This critical value is 9.488. There's my critical region. When I calculate the chi-squared test value in this next step, if that value is greater than 9.488, reject the null hypothesis. Okay, let's see. So chi-squared equals the sum of the observed values minus the expected values divided by the expected values. Okay. I'm going to be even sneakier this time. Watch this. Clear my lists. I don't even know if this is going to work, but I'm going to try it. So edit. My first L1, 44, 24, 8, 15, 6. L2. Well, before I do that, I need the total. Let me get the totals. So I need the totals, right? So I need 44 plus 24 plus 8 plus 15 plus 6. So let's get that first. Let's quit out of here. Let's get those totals. 44 plus 24 plus 8, 6. It's 97. Okay, now let me do my trick. So I go back to stat, edit. So now the expected value here is going to be 0.45 times, what is it? 97. 0.25 times 97. 0.1 times 97. That's just 9.7 for all three of these, because they're all 0.1. We all expect them to be 1/10 of 97. There we go. Okay, so now I'm going to quit out of here. Go to second list, over to math for that sum function, sum of L1 minus L2 squared divided by L2. 4.61 is our chi-squared value. Now, that 4.61, where does that lie along this continuum? It's definitely less than 9.488, not in my critical region. So again, do not reject the null hypothesis. If I got a chi-square test value greater than 9.488, reject that thing. But now, don't. Okay?